Hi everyone, my name is Tang Xingxuan and my lecture number is 148197 from Group 9. In this video, I will discuss about the topic of logic simplifications in digital electronics 2 with the given task. The question states that a function can be described as follows with the function of f with a variable a, b, c, and d equals to product of sum of max term with the entry of 1, 2, 3, 6, 8, 9, 11, and 12. For the first part of the questions, we need to implement this function using only 4 to 1 multiplexer. In order to implement the Boolean functions using only 4 to 1 multiplexer, we must first do the conversion of the POS to SOP of the Boolean functions as shown below. Since the question is given that POS is equal to here, so in order to find SOP, know that the SOP will be equals to the sum of minterms with the remaining entry from the POS. So in this case, the remaining entry will be equals to 0, 4, 5, 7, 10, 13, 14, and 15. So next, we can use 2 power of 4 which is equal to 16 to indicate the combination of the decimal for the SOP in the truth table later on. So next, a truth table can be constructed to implement the Boolean function using 4 to 1 multiplexer. This is the truth table for the Boolean function, and we have 16 decimals from number 0 to 15. And we have variable a here represent as the most significant bit, while for the variable d represent as the least significant bit. We have an extra column for the variable f represent as the output. To determine the bit for the variable f, we need to find the entry for the SOP. And for the entry for a SOP is equals to 0, 4, 5, 7, 10, 13, 14, and 15. So for this entry, the variable f will be equals to 1. For this case, you can see the 0 is 1, 4, 5 is 1, and so on. For the remaining entry, the bit will be 0. So the only 4 to 1 multiplexer circuit is built here. Since the Boolean function consists of 4 different types of variables which are a, b, c, and d, so we needed to build a two-stage multiplexer circuit. So for the first stage of the multiplexer circuit, the input selector will be equals to c and d, which is the least significant bit from the variables. While for the second stage of the input selector, this will be a and b, which is represented as the most significant bit for the variables. While for the first stage, the input data will be equals to the f variable, the bit at the f variable. So the output here will be also represented as the f. So, for example, if we select the bits for the a, b, c, and d equals to 0, from here we can see the output will equals to 1. So if for the next case, if we have a variable d equals to 1, we know that here will be selected, the data 1 here will be selected, which the output will equals to 0. So for the question 1 part 2, we have to obtain the simplest Boolean expression in the form of SOP for the above mentioned functions. And then we need to show the complete truth table and cutoff mechanic. The first step, we have to do the conversion of POS to SOP as shown below. So this is the truth table for the Boolean function. For this case, I will assume that the variable d as the indirect variable. In order to find out what is the value for the EVM, we need to compare the variable f with the variable d. So for the first case, we can see that the variable f is inverse to the variable d. So the EVM will be equals to d bar. For the second case, they are both 0 for the variable f for the decimal 2 and 3. So the EVM will be straightly directly to the 0. This also stems to the decimal 4 and 5, where the variable f is equals to 1. So the EVN also equals to 1. Lastly, we can see that the variable f is equal to variable d. So the EVN value will be equals to d. To construct the 3-bit KMAT, we need to first convert the data from the truth table into it. So for this KMAT, the result will be shown in the minimize functions, and the result will be here. Since the question requires us to find out what is the simplest Boolean expression in the form of SOP, and we know that the d bar is equal to 1. So for this case, we need to convert the value 1 from the previous KMAP into the d plus d bar as shown here. And then we use the knowledge of KMAP, we can find out what is the simplest Boolean expressions in the form of SOP. So the final result will be equals to A C d bar plus A bar C bar d bar plus B D. I think that's all from me. Thank you.